2.1 is representing relations and functions. We'll probably get through this whole lesson. Okay, representing relations and functions. Okay, a relation is a mapping or a pairing. Mapping or pairing. The set of input values is the domain, which we're going to talk about domain and range a lot the rest of this year. So that's my input values, which would be my x usually. Okay, domain goes with your x-axis. And then your range is the set of output values, which would go with your y. So your domain goes with your x-axis, how far I travel on my x-axis, and my range goes with how far I travel on my y-axis. So we're going to be given sets of points, and you're going to tell me if they represent relations or not. So we're going to talk about what that looks like. Let's say that you have ordered pairs, -2, 2, okay, I need space, -2, 2, -2, -2, 0, 1, and 3, 1. Okay, this is how you list it in order pair form. Ordered pairs. And then we could always change it to table form. We're going to have to get used to all of these type of forms. If you have x, you have y. So -2, 2, -2, -2, 0, 1, and 3, 1. Okay, table form. You can always graph it. Okay, if I graph it, I would have -2, 2, I would have -2, -2, 0, 1, and 3, 1. Okay, it's another way to represent it. And the other way to represent it is called a mapping diagram. I don't know if you guys have seen these before. And it's where you have your inputs on one side and your outputs on the other. So if I have -2, -2, 0, 3, I really don't have to list -2 twice. I can just list it once. So if I have -2, -2, 0, 3, my outputs are 2, -2, and 1. So you would draw arrows representing where they go. 0 goes to 1, 3 goes to 1. Okay, so it shows you your inputs and your outputs. That's called a mapping diagram. Those are the 4 ways we're going to look at things today. Okay. We're going to consider the relations given by the ordered pairs, and then from that we're going to state the domain and range, and we're going to represent them using a graph and a mapping diagram. So if I have -2, -3, -1, +1, 1, 3.
Please excuse this interruption. At this time,
2,
all
-2.
students need to be in your second bell class. All students in your second bell class.
3, 1. Okay? So I have all of these, and I want to know what is the domain and range? Okay? So, domain is what? What is domain? In your x. So when I'm looking just at ordered pairs here, I literally list all of my x's for my domain. So what is my domain in this case? What's my domain here? -2. What's my domain here? -1. Domain 1, 2, 3. If they repeat, I don't have to write them twice. Okay? But I always want to write them from least to greatest. Okay? Now, the same thing happens for your range. Your range goes with your output or your y value. So what is my range? -3, and then 1. What else? -2 and +3. I only have to list 1 once, even though there's 2 of them, because it's the same, it's the range. It doesn't repeat, so you can leave it that way. Then it says, represent the relation using a graph and a mapping diagram. So graph and mapping diagram. So how do I graph this? What do I do to graph all these things? I'm going to start by graphing -2, -3. So I go to -2, I go down 3, I have a point. I'm going to graph -1, +1, I put a point. I graph 1, 3, I put a point. I go to 2, -2, point, and 3, 1, point. So now I've graphed all of those relations, okay? Then I have to turn it into a mapping diagram, which means I have to put my 2 boxes with my input and my output. And literally, I can just copy what I did in domain and range and draw arrows. So in domain, I have -2, -1, 1, 2, and 3. And in my output for range, I have -3, -2, 1, and 3. Now I draw my arrows. -2 goes with -3. -1 goes with 1. 1 goes with 3. 2 goes with -2, and 3 goes with 1. And that's how you're going to draw your mapping diagrams. Can you handle that? That shouldn't be too bad, I don't think. Then we come to deciding if something is a function, okay? A function, the definition of a function, is a relation for which each input has exactly one output. Each input has exactly one output. So if I have, like on here, I have -2, -1, 1, 2, and 3. This would be considered a function because each input has exactly one output, okay? Over here, though, I have -2, -2, 0, 3. -2 has 2 different outputs, so this is not a function, okay? So if my input has more than one output, it is not a function. So then they give us an example, and they say, tell whether this is a function. And they say your inputs, your outputs, I'm going to put 2 up here, in, out, okay. 2 separate ones. Let's go -3, -1, 2, and 4. And we're going to go 2, 3, -4, we're gonna go boom, boom. And then we're gonna go -2, 1, 4. And we're gonna go -4, -1, 2, 3. This goes here. This goes here, here, and that goes straight across. Okay. Is this first one a function? Does each input have one output? Does -3 have one output? Yes. Does -1 have one output? Does 2 have one output? Does 4 have one output? Yes. So my outputs can repeat. Okay? My inputs cannot. Okay? So this here is a function. Now, if you look at this one, does -2 have one output? 1 have one output? No. So this is not a function. That's how you decipher. Okay? Depends on if you have more outputs to your inputs. Okay? So you're going to start with that. Another way to tell if something is a function or not, if it's graphed, is through the vertical line test. You guys remember the vertical line test? Okay. This is the best because when it's graphed, it makes it so much easier. So if I have a graph, okay, let's say I have one that faces this way, and let's say I have one that faces this way. Okay? Something is a function, okay, if I can draw a vertical line through it and it only crosses through the graph once. Okay? So if I can draw a vertical line through this anywhere and it only crosses through once, it's a function. But on this one, if I draw a vertical line through here, it crosses twice, which means it's not a function, because what would happen is, let's say this is 3. 3 would have two outputs, a positive and a negative. So that's not a function. So if you have something graphed already, you can do the vertical line test through it to see if it is a function or not. Makes life so much easier. Okay, so this one's not. That's probably my favorite thing in this whole section is the vertical line test because it makes life simple. Okay, so if you draw a vertical line through something and it only goes through that graph once, it is a function. If it goes through more than once, it is not a function. So then we're going to get to the last part, which is graphing equations into variables, which I know you know how to do this. Because I know you've done it with Mrs. McCain before. So tell me, how would we graph this? Let's say we're going to graph y equals -2x minus 1. What form is this in right now? Slope-intercept, right? Slope form, okay? So I have an equation. I'm going to graph this, okay? How am I going to graph this? There's two ways that I can do this, okay? I can recognize it's in slope-intercept form, and I can go to the slope, and then I can do I can go to the y-intercept, and then I can do the slope. But tonight on their homework, they want you to graph it by plugging in points, okay? So first step is construct a table of values. So if we're going to construct a table of values, your homework should look something like this. You should have an X and a Y column, and we should be able to put inputs and outputs in, okay? If you are doing this, what numbers can we plug in? What numbers do you want to plug in? I would say plug in some negatives, plug in a 0, and plug in some positives, like 5 total numbers. So I would always, if possible, plug in like -2, -1, 0, 1, and 2, because they're easy numbers. Does that make sense? Okay. So if I plug in -2 in this equation, I have y minus 2, or I have y equals -2 times -2 minus 1. What's -2 times -2? Positive 4. What's positive 4 minus 1?
3.
3. So you would get 4 minus 1, which is 3. If you plug in negative 1, what's negative 1 times negative 2? Positive 2 minus 1 is 1. Yeah. Write the wrong thing, thinking the right thing. If I plug in a 0, I have negative 2 times 0 minus 1 equals, what is negative 2 times 0? 0. So then 0 minus 1 is negative 1. If I plug in a 1, what is 1 times negative 2? What is 1 times negative 2? Negative 2. And then I have negative 2 minus 1, which is? Negative 3. Good. And then the last one would be y equals negative 2 times 2 minus 1. What's negative 2 times 2? Negative 4. And negative 4 minus 1 is? Negative 5. So there is my first step. Construct a table of values. I showed you all the work because sometimes I have to do that way. Step 2 is plot the points, and then step 3 is connect the dots. So step 2, plot points, and I'm going to write step 3 right here too. Connect the dots. Connect the points, okay? So we're going to do that all on one thing. So if I plot these points, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I'm going to go to negative 2, positive 3, and plot a point. I'm going to go to negative 1, 1, and plot a point. 0, negative 1, and plot a point. 1, negative 3, plot a point. And 2, negative 5, plot a point. From there, I simply connect my dots. And now I have graphed y equals negative 2x minus 1. Okay. This example right here is considered a linear function because it can be written in the form y equals mx plus b, so this is a linear function. Where m and b are the constants, we talked about that already. The graph of a linear function is a line, so that you can write it in function notation. If you see an equation written like this, f of x equals negative 2x minus 1, it's the same thing as if the y were there. You still graph it the same way, you still treat it the same way. This is what's called function form, okay? This is function form, and you're going to start seeing that a lot this year. So when you see that, don't get confused, it's the same thing, okay? This is what 2.1 is over. So we're going to do some homework.